So far, we talked about a second order linear differential equation with constant coefficients, like a, the second derivative of y, plus b, the first derivative of y plus cy equal to 0. So we saw that before the auxiliary equation. And then based on what we have for the roots, we start writing the general solution. If we have distinct roots and they are real roots, then y is equal to c1 e2 m1x plus c2 e2 m2x. If we have a repeated root, m1 is equal to m2, then y becomes c1 e2 m1x plus c2x e2 m1x. And finally, if we have complex root, m1 is alpha plus I beta, and m2 equals to alpha minus I beta, and the general solution is e2 alpha x parentheses c1 cosine beta x plus c2 sine beta x. I expect you to ask, what if we have nth order linear homogeneous differential equation with constant coefficients? What is our approach? So in that case, again, we form the auxiliary equation. For the auxiliary equation, if we have distinct roots, like m1, m2, and so on, then the general solution can be written as y equals to c1 e2 m1x plus c2 e2 m2x plus the rest of the terms cn e2 mnx. This is our general solution. If we have the second case with repeated solutions, then y becomes c1 e2 m1x plus c2x e2 m1x plus c3 x squared e2 m1x plus the rest of the terms the last term can be written, let me move this a little bit, cn x2 n minus 1 e2 m1x. And finally, in the last case, if you have complex roots, we're going to follow what we learned before. Let's go over one example to feel more comfortable about this situation. In our example, question says, solve the third derivative of y plus 3, the second derivative of y minus 4y equal to 0. So first, we construct the auxiliary equation. We get m cubed plus 3m squared minus 4 equal to 0. So our goal is to solve this equation. To solve this equation, well, we can use factoring. Well, m minus 1 times m squared plus 4m plus 4 is equal to 0. So m is equal to 1, and m is equal to -2, which is a repeated solution. Very good. Now we're going to write down the general solution for this differential equation. Well, y is equal to, for the solution m equals to 1, we get c1 e2 1 times x, or e to the x, plus. Now for the repeated solution, we get c2 e2 negative 2x plus c3x e2 negative 2x. That's the general solution for this differential equation of order 3.